So hi everyone. Today we will try to understand what are Markov models, uh, and later on we will try to understand what are hidden Markov models. So a Markov model is a model that it's more of an ecosystem which tells us about the probabilities of a sequence of random states in a particular environment. So eventually, considering the case of weather, a Markov chain can be a system that would be telling ki what can be the weather tomorrow, given today is sunny, or if today is rainy, what would be the weather tomorrow? It can be it can be cold, or it can be hot, etc. So a Markov chain makes a very strong assumption. A very big property of this Markov chain is that the future state in the Markov chain is always determined by the current state and has nothing to do with the past states. So, for example, if in a Markov chain you're trying to predict what would be the weather tomorrow, so the weather tomorrow will depend only on the current state, that is today's weather, and not on yesterday's weather also. So in historic date, whatever has happened, but if we are going to forecast for the future, we would be considering just today's state. So let's consider an example for a better understanding, where we are considering the environment of weather, where we can have three states: hot, cool, or rainy. So as you can see in the example, where we have the blue nodes as the weather, and the numbers that are written as probabilities of happening of the next state if current state is the blue state. So for example, if we are standing at hot, so the next day there is a probability of zero point 0.6 that the next day would also be hot. Also, there is a probability of zero point 0.1 that the next day can be cold, and zero point 0.3 that the next day can be warm. Similarly, you can read the other states as well, where you can see cold, and it is a probability that if today is cold, so tomorrow there is a probability that it would be 0.8 percent, 80% chances that tomorrow will also be cold. Just 1%, 10% chances that it would be warm tomorrow, and 1% chance that it can be hot tomorrow. As you can see, the arrowheads going. So this is how a Markov chain works. Now, in a Markov chain, there are majorly three major terminologies that we use. One is the number of states, the blue nodes that we saw, between which the probability has been mentioned. A transition probability matrix. That is, it gives us from when we move from a particular state 1 to state 2, what is the probability. So it can be taken as a matrix, n cross n matrix, where n is the total number of nodes, similar to a correlation matrix, if you remember, where we have the even the rows and column names as the features only. So consider to, like in this case, hot, cold, and warm, consider to be a 3 cross 3 matrix, where we would be having the rows as hot, cold, and warm, column also as hot, cold, and warm, and eventually we will be filling in values for those probabilities. Key, the transition from hot to hot is zero point 0.6, from hot to cold is 0.1, and from hot to warm is 0.3. Similarly, we'll be filling out other values as well. So a transition probability is basically transition from state 1 to state 2. Now this states can be anything, and the last would be an initial probability distribution. So this probability refers to what state would be the first state. So if we haven't been given any initial state, so for example, if we don't know where to start this Markov chain, if we don't have the past data, so if we don't have the past days weather, so what is the initial probability distribution that we can use? That is represented by sigma.